In this video, you are going to learn about subsets, strict subsets, and supersets. What is a subset to start with? A subset is a set within another set. Let's take these three sets to illustrate what subset is, strict subset, and supersets. So let's say we have set X with these elements. Set X has this element 3, 5, 6, 7, 8, 9, and 10. Let's stop at 10. And then we have set Y with these elements. So we have 5 as a member, 7 as a member. We have 8 as a member. We have, let's stop at 10. Let's include 10 as well. And then we have set Z with these members. So we have 9. Let's say we have 9, we have 3, we have 6, and then let's include 10 again. All right. Okay. So can we say that Y is a subset of X, which we are going to write as this? Y is a subset of X. Can we say that? Let's look at that. Before we can say that Y is a subset of X, all the elements of set Y must be present in set X. That is, we must have the same element that we have in Y in set X. So let's see. We have 5 here, there is 5 here. We have 6 and we have 7, and then we have 7 here. We have 8, and then we have 8 here, and then we have 10, and we also have 10. So we can boldly say that Y is a subset of X, let me just write it here like this. So Y is a subset of X. Again, we can say that Y is a strict subset using the symbol of X. This means that every element in Y is present in X, but not all the elements in X is present in set Y. So we say that Y is a strict subset of X in this case. Y is a strict subset of X. Let's take more example. Can we write Y as a subset of Z? That is Y as a subset of Z. Can we? So we need to check. So here we have Y, and here are the elements here. So here we have 5. 5 is not here, 7 is not here, 8 is not here, and then 10 is here. Okay, but we cannot say that Y is a subset of Z because we don't have all the elements in Y in X. We cannot say that Y is a subset of Z because we don't have all the elements of set Y in set Z, even though we have 10 and 10 here, but we don't have 8 here. So this is false, not correct. Another example is, can we say that Z is a subset of X? For Z to be a subset of X, all its elements must be present in X. So we need to check. So we have 3 here. 3 is also in Z. Okay. 9 is here as a member. 6 is here. 6 is here as a member. And 10 is here. 10 is also here. So we can say that Z is a subset of X. And remember, we can also say that Z is a strict subset of X. I've explained this. That is, all the elements of Z are in X, but not all the elements of X are present in Z. We can also reverse the way we write these notations to illustrate supersets. So here we say that Y is a subset of X, so we can also say that X, by reversing it, is a superset of y like this. Yes. This means that x contains every element that is in y or even more. So we rate this as x is a superset of y. X is a superset of y. Or we can say that x is a strict superset of y. What does this mean? This means that x contains everything that is in y, but some elements of x are not in y, just as you can see. This is where we are going to stop today. Thank you. Expect my next video lessons about algebraic set notation. Goodbye.